Number 1, the figure below shows a 480 watt, so this is the power of immersion heater used to melt ice in a container in 120 seconds. So this is the time 120 seconds. The reading of electronic balance decreases by 0.172. Okay, this is mass loss. Okay, mass loss. A. What is mass loss? What is the mass of ice that has melted during the heating period? B. Calculate the specific heat, latent heat of fusion of ice. So first question A, the mass of ice that has melted. Actually, the mass loss lah. Right. Okay, so how we are going to answer question A? A, of course, the answer is mass loss, mass of ice that has melted is equal to 0.172 kg. Okay, B, calculate the specific latent heat of fusion of ice. Okay, so we know that heat loss is equal to heat gain. Heat loss by who? By the immersion heater, and heat gain by the ice, alright, is equal. So heat loss, question B. Okay. Assumptions that we made for this chapter. One is we assume that all heat supplied by the immersion heater, okay, is absorbed by the ice. Okay, alright. And we assume that no heat loss to the surrounding. So all the heat loss will be absorbed by the ice. Heat loss by the immersion heater, so PT is equal to heat gain of melted ice, right? So melted ice is ml. Okay, we are going to find specific latent heat of fusion of ice. So L is equal to PT over M. Okay, our power is 480, 120 seconds divided by mass 0.172. Mass of ice that has melted. Okay, not the original mass of ice. So we have to beware. Alright, so the answer is, hit your calculator. So the answer is 3.35 times 10 to the power of 5 joules per kilogram. Alright, example 2. What is the amount of heat supplied by water heater to change 0.75 kg of water at 30 degrees Celsius to steam at 100 degrees Celsius? State the assumptions you make in your calculations. So, assumptions. Okay, number 1, all heat supplied by the water heater is absorbed by the water. Okay, so number 2, we assume that no heat loss to the surrounding during heating. Alright, next. What is the amount of heat supplied? Okay, we want to find Q by a water heater to change 0.75 kg of water at 30 degrees Celsius to steam at 100 degrees Celsius. So I suggest you to draw the diagram. Okay, we want to find the heat energy, okay, to change water at 0.5 kilogram of water at 30 degrees Celsius to steam 100 degrees Celsius. So in the process, okay, if you want to change water to steam, okay, before the water can be converted into steam at 100 degrees Celsius, so in between here, okay, the water has increased in temperature at 100 degrees Celsius before it turns its physical state to steam. Alright, So here we have change in temperature, but not physical state of matter. Alright, so here we have mc theta. Okay, specific capacity. Okay, specific capacity. The energy required to change the temperature of 1 kg substance by 1 degree Celsius. So there is change in temperature but not the physical state. Here we have the change in physical state but at constant temperature. Here we have latent heat, right? So Q is equal to ml. So in order to get the energy required to change the water to steam, so we have to consider the heat change. Okay, the energy required to change the water at the same state but different temperature, and we want to change the physical state from water to steam at constant temperature. So if we want to find the energy required, Q is equal to Q1 here plus Q2. Okay, so mc theta plus ml. So mass of water, specific capacity of water, and heat change for water. Temperature change from 30 degrees Celsius to 100 degrees Celsius. So change in temperature is 70 degree. Okay, M here is mass of the steam or water is the same as constants, so 0.75. L is specific heat capacity, specific latent heat of steam. Alright, so specific heat the specific latent heat of steam or vaporization of water. So we have 2.26 times 10 to the power of 6. Alright, so hit your calculator. So we will get 1.92 times 10 to the power of 6 heat in joules. So don't forget your unit. That's all.